So one of the things you have to be able to do is you have to be able to pick a buffer system for a given pH. So the way we select or pick buffers is buffers work at plus one, minus one of their pKa value. So that's why we care so much about the pKa. We got into that. And remember, it's the negative log of the Ka gives you the pKa. It's missing the negative log there. So what you would do is if they ask you to select a buffer, generally on the AP exam, they're going to give it to you in Ka values. But remember, pKa is the value we need, and we choose a conjugate pair with the weak acid as the pKa closest to that of the needed pH is essentially what you're going to do. So here's like a typical problem. They're asking me, hey, I need to make a buffer with a pH of around 7.5, right? And we know that the buffers only work, they have a range, kind of like your cell phone has a range of plus or minus 1 up or down of the pKa value. So this, we're looking at a buffer at 750, it would buffer to 8.5 and 6.5, plus or minus 1. That's how they work. But how do you pick them? Well, they'll give you a Ka chart like this, and what the first thing I'm going to do is pop these in my calculator. So I'm going to go 3.5 e to the negative 8, take the negative log of it, I get 7.46 is my pKa value. So I'm changing the Ka by negative logging it into the pKa. So then 6.2 e 8 negative log, that's going to be 7.21. And then I'm going to take 8e to the negative 8th. I'm going to negative log that sucker. I'm going to get 7.10. And the last one is 4.3e negative 7th log, negative log. I get 6.37. So when we go and look for possible buffers, this one automatically cancels. Why? It's outside the range, remember, because it has to be within 1 pH unit of the pKa value. But the best buffer is the one that's closest to the desired pH. See how this pKa is 7.46 and our desired pH is 7.50? That would be our best buffer. So we're going to take HOCl, which is the weak acid, and then you're going to add HOCl, and then you're going to add OCl minus. But remember, we can't add an ion it's got to be solid when you weigh it out. So that's why if you see on the test, it would be Na. They always use Na because it's a cross-out ion. So you put in NaOCl and HOCl. Well, the Na crosses out. I have my weak acid, my HA, and I have my A minus, my conjugate base. And that is going to be my buffer system. And because the pKa value is closest to the desired pH, I know that that's going to work really well. The other aspect is buffer capacity. Buffer capacity, if one of the components gets used up or consumed, right, then the system won't be a buffer anymore because you need both components. Because remember, I gave the example of like paper towels and sponges to clean up messes, right? Well, same thing. We have our acid, we'll have the conjugate acid and the weak acid, the conjugate base and the weak acid. If one of those gets consumed, what happens then is that it will cause the system not to be a buffer anymore. So capacity. So what happens is if the added HCl wipes out all the conjugate, so it takes all the A minus out of there, that no longer, if it has HA but it doesn't have any A minus, right? It takes out all the little A minuses. What happens then is, because the A minus is a little pink one, right? So they all get wiped out. It's like using up a roll of paper towel. Use up a roll of paper towel, you're not going to be able to absorb any more spills because we're talking about absorbing. So think of buffer capacity like this. The more you have, the more paper towel you have, the greater the capacity is going to be. So the more buffer you have there, and we talk about moles or molarity, really molarity is concentration. So the higher the molarity, the more paper towels, the more sponges you have, the greater the buffering capacity is going to be. And that's what we mean when we say buffering capacity. It's how much can it absorb. So you're just looking for the greatest amount. More paper towels, more absorption. More sponges, more absorption. That's how buffer capacity works.